simplex method, for converting inequalities into equalities, we are adding only slack variables. So in LPP, we can use graphical method, BigM method, simplex method and two-phase method. The purpose of artificial variable is to help in getting an acceptable. The RHS value should be always positive. If you get negative, you have to multiply this by -1. So artificial variable is a non-negative variable. That means you have to add Hello everyone, welcome back to my new session. I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. In my last session, I have discussed about simplex method. I have explained different types of problems in simplex method. Please practice all the problems. Today I will explain BigM method. So what is this BigM method? So what is the difference between simplex method and BigM method? So I will explain in this session. So let's get started now. I will explain BigM method. BigM method is a method of solving linear programming problem. So in LPP, we can use graphical method, BigM method, simplex method and two-phase method. For solving LPP, we can use 4 different types of method and already have discussed about simplex method. So simplex method is a method to solve a linear programming problem. As usual, BigM method is also a method to solve a linear programming problems using the simplex algorithms. So using simplex algorithms, we can solve BigM method. So BigM method is a method to solve a linear programming problems. The BigM method extends the power of the simplex algorithm to problems that contain greater than constraints. So in BigM method, you will get greater than constraints. So usually in simplex method, we are getting less than or equal to constraints. So if you get greater than or equal to constraints, so how to solve that greater than constraints in BigM method? So I will explain everything in this session. So BigM method is very important concept. If you learned simplex method, easily you can solve this BigM method. Only one step you have to extend. So BigM method extend the power of simplex algorithm. So here you will get the greater than constraints. So if you get greater than constraints, what you should do? So in BigM method, so this is your algorithm for BigM method. In the simplex method, only those LP problems where constraints add less than or equal to sign. So only those less than or equal to sign you will get in simplex method. But in BigM method, LPP having constraints with less than or equal to, greater than or equal to or equal sign can be solved. Keep in mind, in simplex method, we'll get less than or equal to sign. But in BigM method, we'll get greater than or equal to, less than or equal to or equal sign to be solved. So how to solve this constraints in BigM method? And in BigM method also, the problems has to be first brought into standard format. So next step is all the inequalities you have to convert it into equalities by adding what? In simplex method we are adding slack variables, but here we have to subtract the surplus variable with artificial variable. That I will explain with an example. And the objective function has to be maximization. If it is minimization, you have to convert it into maximization by multiplying -1. So the objective function has to be maximization type in BigM method also. And all inequalities have to convert it into equations. So all the inequalities means less than or equal to, greater than or equal to or equal sign. All inequalities you have to convert it into equalities. Then how to convert this into inequalities? Next I will explain. And the RHS of all constraints should be non-negative. Example, x1 plus x2 less than or equal to 21. So RHS means this is the RHS value. The RHS value should be always positive. If you get negative, you have to multiply this by -1. If you get negative 21, so you have to multiply this by -1 to convert it into positive RHS value. So these are the steps you have to follow in B.C.A method also. So first, in B.C.A method, all the objective function. So here we have to use some rules and regulation. Objective function has to be maximization, and all inequalities you have to convert it into equalities, and the RHS of all constraints should be non-negative in B.C.A method also. And the next step, the constraint or inequality with less than or equal to sign can be converted into equation by adding slack variables in simplex method. In simplex method, for converting all inequalities into equalities, you have to add slack variables as shown in the simplex method. And the constraint or inequality with a greater than or equal to sign can be converted into equation by subtracting a surplus variable. Subtracting a surplus variable with, and also at the same time adding artificial variable in B.C.A method. Keep in mind, if you get greater than or equal to symbol or equal to symbol, if you get greater than or equal to symbol in B.C.A method, you have to subtract a surplus variable with artificial variable A1, A2, etc. Surplus variable should be S1, S2, etc. So in simplex method, for converting inequalities into equalities, we are adding only slack variables. But in B.C.A method, if you get greater than symbol, greater than or equal to constraint, so you have to subtract this surplus variable with artificial variable. I will explain with an example. Example, I have x1 minus 2x2 minus x3 greater than or equal to 15. So this is my constraint in B.C.A method. So how to convert this inequalities into equalities? In B.C.A method, for converting this inequalities into equality, we have to subtract this surplus variable with adding, at the same time adding a artificial variable. I'll repeat, this is inequality constraint. For converting inequality into equality in B.C.A method, we have to subtract the slack variable with adding artificial variable. So now this is in standard form is equal to 15. So now this is in a standard form. So this is called B.C.A method. So all the inequalities you have to convert it into equalities by subtracting the surplus variable plus adding the artificial variable to your constraint. In B.C.A method, you have to use this method. And artificial variable. What is the meaning of this artificial variable? So artificial variable is a non-negative variable. That means you have to add the artificial variable. So artificial variable is a non-negative variable added to the LHS of each constraint. So we are adding the artificial variable to the LHS of each constraint, either greater than or equal to or equal type in a LPP. Listen carefully. This artificial variable is a non-negative variable. It's always should be positive. It is a non-negative variable. It is added to the LHS of each constraints with either greater than or equal to symbol or equal to type in LPP. So, in B.C.A method, you will get greater than or equal to or equals type of constraints. So, if you get greater than or equal to type of constraint, you have to subtract the surplus variable plus adding artificial variable. And if you get equal sign, what you should do is, if you get equal sign in B.C.A method, you just add the artificial variable. You are not supposed to subtract this surplus variable when it is in equal type. You just add the artificial variable when it is in equal sign. Got it? And example, 4x plus 2y is greater than or equal to 180. So here I have one constraint. This is my constraint, 4x plus 2y is equal to 180. 4x plus 2y greater than or equal to 180. So here it is in greater than or equal to type. Here I will convert this inequality into equality by subtracting surplus variable and adding artificial variable. So now it is in standard form, and 4x plus 2y minus s1 plus a1 is equal to 180. This is in standard form. One more example, 4x plus 7y plus 5z greater than or equal to minus 3. Minus 4x plus 7y plus 5z greater than or equal to minus 3. So, what is the rules we have to use here? All the RHS values should be positive. Otherwise, we have to convert it into positive by multiplying minus 1. So, this is my first step. Convert this minus 3 into plus 3. So, multiply minus 1. So, 4x minus 7y minus 5z greater than or equal to plus 3. Minus 3 changes to plus 3. So, now you can convert this into standard form. 4x minus 7y minus 5z by subtracting the surplus variable 2, because already in first constraint I have added s1. So, in second constraint it is minus s2. Subtracting the surplus variable with second artificial variable a2 is equal to 3. So, this is your standard form in B.C.A method. So, 4x minus 7y minus 5z minus s2 plus a2 is equal to 3. Now, it is in a standard form. Here, a1 and a2 are artificial variables. The purpose of artificial variable is to help in getting an acceptable. What is the purpose of adding artificial variable? It is help in getting an acceptable, that means non-negative initial basic feasible solution to the LPP. So, if you are adding this artificial variable a1 and a2, here we have the surplus variable minus s2. If you are adding this plus a1 or plus a2, so it will give the initial basic feasible. If you are adding a1 and a2 artificial variable, it will give the initial basic feasible to your solution. So, that is what we are adding. A1 and A2 is a artificial variable. 2 marks question. What is the purpose of artificial variable? So, this is about your basic things in B.C.A method. So, first step is slack variables are added to the LHS of less than or equal to type constraint. So, that is in simplex variable, and surplus and artificial variables are added to the LHS of greater than or equal to type constraints, and there is no need for either slack or surplus variables for equal constraint. There is no need to add slack variable and surplus variable to the equal constraint, and artificial variable is introduced on the LHS of each equal type constraint. So, if you get equal type constraint, you just add the artificial variable a1, a2, a3 up to an. So, you can add this artificial variable to the equal sign. So, for greater than or equal to type, you need to subtract the surplus variable with artificial variable, and if you get less than or equal to type, you just add the slack variables for converting inequality into equality type. Let's see the examples for surplus variable and artificial variable. 8x1 plus 16x2 plus 12x3 greater than or equal to 250. So, here we have greater than or equal to constraint. So, what you should do is, for this constraint values, you have to subtract the surplus variable plus artificial variable. You have to subtract the surplus variable plus artificial variable A1. This is first constraint. I have converted this into inequality. I have converted this into standard form. And the second constraint, greater than or equal to 80. Again, we have greater than or equal to 80. So again, I am converting this inequality into equality by subtracting the second surplus variable called S2 plus artificial variable 2 is equal to 80. And the last constraint is the third constraint. Again, we have greater than or equal to 105. So this is my third constraint. So here S1, S2 is finished. Now again I am subtracting the third surplus variable called S3 plus artificial variable A3. So this is equal to 105, where x1, x2, x3 is greater than or equal to 0. So like this, you have to convert this inequality into equality by subtracting surplus variable plus artificial variable in Big M method. And also, if you get equal type constraint, you have to add only the artificial variable. So this is about your Big M method. If you know the concept of simplex method, easily you can solve Big M method also. But beginning, you have to use this technique in Big M method. And the next topic is removal of artificial variables from the initial basic feasible solution. So already I have told you about artificial variable A1 plus A2 up to A1, AN. So if you get equal type constraint, you can add this artificial variable. And if you get greater than or equal to constraint, you can subtract the surplus variable with artificial variable, right? So here we got the artificial variable A1 plus A2 plus A3, etc. So this artificial variable will add it to the initial simplex table or in iteration 1 or iteration 2 or iteration 3. So here, if you get A1, A2 in initial simplex table or in iterations, so this will remove in every iteration. So you have to remove this in every iteration. So how to remove this in every iteration? That is your concept. Removal of artificial variables from the initial basic feasible solution. If you are removing this artificial variable in every iterations, so you will get the optimal solution. Optimal feasible solution you will get if you are removing this artificial variable in every iteration. If it is deleting in every iteration means, so you will get the final optimal solution. So here in the final solution to an LPP in which artificial variables are present is not an acceptable solution to the LPP because the artificial variables do not have any meaning in the context of the problem. So this artificial variable is not having any problem. This artificial variable is do not having any meaning, but we are adding the artificial variable for getting the initial basic feasible solution. At the time, we have to delete, we have to erase this in every iteration for getting the initial basic feasible solution. So how to delete this artificial variable A1, A2, A3, etc.? By using Big M method and two-phase method, we can delete this artificial variable in every iteration. So this is your concept. So how to delete this artificial variable? By using the Big M method and two-phase method, we can delete this artificial variable for getting the initial basic feasible solution. And the next topic is special conditions in Big M method. Already I have discussed this unboundness in graphical method and also in simplex method. What is this unboundness in Big M method? If the column with the maximum positive value of Cj minus Zj, column with maximum positive value with Cj minus Zj has negative or 0 values for all its elements. So again, in ratio, if you get any negative values or 0 or infinite values, so you can't select the key rows. Already I have explained this in simplest method. If you get any negative values in ratio, you can't select the key rows, right? So if all the ratio values are negative, we can't select the key rows. This condition is known as unboundness. Unboundness solution. If you get the ratio value is negative, means that is unbounding solution. So in this case, we cannot proceed further with simplex iteration to arrive at an optimal solution. If your ratio value is negative, means we cannot move further because there is no selection of key row. Then we can't move further. So we have to stop the iteration table there. So this condition is known as unboundness. So it is a special conditions in both simplex method and big M method and in two-phase method also. And the next condition is degeneracy. So what is this degeneracy? It is a new condition in big M method. It may also happen that in a particular simplex table, sometimes you will get it in simplex table also. What is this degeneracy? The minimum ratio may occur in more than one row. So usually in ratios, using this ratio values, we can select the key row, right? So you have to select least positive value. Least positive value we are selecting for finding the key row, right? If you get same least value, both the values are same, then how will you select the key rows in simplex method or big M method? So this condition is known as degeneracy. So in row, the minimum ratio may occur in more than one row. If you get more than one time, so this condition is known as degeneracy. So in this case, there is a tie for outgoing variable. So usually using this least positive value, we are selecting the outgoing variable, right? Sometimes you will get same ratio values. So how to select this outgoing variable? So this condition is known as degeneracy. Sometimes there is a tie for outgoing variable. This condition is known as degeneracy. If you get any degeneracy, there are rules to break the tie. There are rules to break the tie and select an outgoing variables. So we have some techniques for breaking the tie. If you get tie between two numbers, so we can overcome that problem, but we have to use some rules to break the tie and select the outgoing variable. And so while doing the problems, I will explain about degeneracy with an example. In ratio, if you get the same value, same least value, then how to break that rules. I will explain with an example. So this is about your two special conditions in big M method, that is unboundness and degeneracy. So next topic is steps in big M method or penalty method. So big M method is also known as penalty method or chance method. Chance. Big M method is also known as penalty method or chance method. So what are the steps we have to use? If the problem is minimization, convert it into maximization, and through multiplying the objective function by -1. So these are the steps for, these are the steps we have to use while doing the big M method. So first step, minimization to maximization by multiplying the objective function by -1. And in any of the constraint, if the RHS coefficient is negative, make it positive by multiplying again both the sides of the constraints by -1. So this will help to convert the inequality sign into the equality constraint. So this is second step. And the next step is, in the constraint, introduce slack, surplus and artificial variables on the LHS. So to convert the constraints into inequalities. By converting all the inequalities into equality, we have to introduce slack variable, surplus variable and artificial variable. And if the constraint is greater than or equal to, add only slack variable. Next step is, if the constraint is less than or equal to, add only slack variable on LHS. And if the constraint is greater than or equal to, subtract surplus variable and add artificial variable. And if the constraint is equal to, add only artificial variable on LHS. So these are the main steps we have to use in big M method. We have to introduce slack variable, surplus variable and also artificial variable in big M method. So this is about your big M method. So what is the difference between simplex method and big M method? In simplex method, we are introduced only slack variable. But in big M method, we are introducing slack variable, surplus variable and also artificial variable. So in big M method, you will get greater than or equal to symbol and also equal sign constraints. Already I have discussed about greater than or equal to and equal sign. If you get greater than or equal to in big M method, you just subtract the surplus variable with artificial variable, and if you get equal sign, you just add only the artificial variable. So this is about your big M method. So in my next session, I will explain with an example. So I will discuss big M method problem. Thank you.